This is a video created to accompany the music education research text by Miksza, Shaw, Richerme, Hash, and Hodges. In this video, we'll walk through how to use SPSS to conduct analyses and produce plots for examining differences with nominal level outcome variables, similar to those presented in the Determining Differences with Inferential Statistics chapter of our text. We'll use the file labeled Differences Chapter Nominal Data.sav, which was created to accompany this chapter and is available among the online supplemental materials for our book. In this video, we can begin with the hypothetical scenario in which we are interested in comparing students who are selected into all-state choir as a function of whether they are eligible for free or reduced lunch at their schools. Both variables in this case are categorical in nature, that is nominal, and so we can use a clustered bar chart to visualize them. If we navigate to the Graphs menu, to Chart Builder, reset, and from the bar option, choose the clustered bar chart, and move that into our blank space. Take our all-state choir yes or no variable into the x-axis, and whether students are eligible for free or reduced lunch or not into the cluster as the cluster variable. And click OK. And we could see the relative disparate frequencies between students who are eligible for free and reduced lunch and were accepted into all-state choir or were not. Since different individuals belong in each of the categories created by the variables in this scenario, the chi-square test would be the appropriate test to use with these data. To conduct this analysis, we can navigate to Analyze, to Descriptive Statistics, to Cross Tabs. Then we can enter all-state status for year one as the row field and eligibility for free and reduced lunch as the column field. We can also select the cells menu to request percentages of the participants belonging to each of the categories. Continue. And if we select the statistics menu, we can then ask for the chi-square test, as well as the phi coefficient, which would be a measure of effect size in this case, and click continue. Confidence intervals are not reported with chi-square tests. So we're ready to go, we can click OK. And so we get a bunch of information from SPSS, the number of participants that contributed to this analysis, 300, the percentages of participants and the frequencies of participants in each cell of this cross-tabulation between these two nominal variables, and the results of the chi-square test, this top line here, and we see the p-value, or the significance value, is less than 0.001, and since that is below our traditional threshold of 0.05 for statistical significance, we would reject the null hypothesis of no difference in all-state choir acceptance as a function of free and reduced lunch. Going down further, we see a phi value of 0.28, which suggests that this is a small to moderate effect size. I'm going to close this window here since we don't need it. For our last example, let's assume we are interested in determining whether the students who were selected for all-state choir in year one were also likely to be selected the following year. Again, a clustered bar chart could be helpful for visualizing this difference, and we'll hop into the Graphs menu and the Chart Builder option, reset, choose the clustered bar chart format, drop it into the empty field, put all-state choir status in year one as the x-axis, and all-state choir status in year two as the clustering variable. Click OK. And here we see some disparities in the number of students who were in all-state or not each of the following years, both years. So the Mcneemar test is the appropriate test to use with these data. And to conduct this analysis, we would again navigate from Analyze to Descriptive Statistics to Cross Tabs. I'll reset our features here. We could put all-state status for year one in the rows field, and all-state status for year two in the columns field. And again, we can ask from the cells menu for the total percentages by each cell in this cross-tabulation. And in the statistics options, we could ask for the Mcneemar test, and again, the phi value for an effect size, and click continue. Click OK, we're ready to go. Again, we see that there are 300 participants that contribute to this analysis. We see the cross-tabulation, where we see the counts or the frequencies of participants in each category and their percentages. And then the Mcneemar test here with its p-value, its significance value, which is 0.20. 0.20 is not below the traditional threshold of 0.05, it's much larger, so we would fail to reject the null hypothesis in this case, that students who were accepted in 1 year are more or less likely to be accepted in the next year. We wouldn't necessarily be interested in the phi coefficient as an effect size indicator here because the effect itself was non-significant. We hope that this video was valuable, and thank you very much.